The most important phase in the life of any teenager is when they are about to graduate from high school or intermediate college, as they would call in the subcontinent. They make the most important decision of their life, what they want to do for the rest of their lives, and it all boils down to two things: what school or university they want to go, and second, choosing the right major. Myself being an electronic engineer, I'm going to be biased today and discuss the electrical and computer engineering major in depth and how this could change your life forever. So what is electrical and computer engineering? I'm going to refer electrical and computer engineering as ECE for the rest of the presentation. I went through many top schools engineering websites to find that out. After scanning through various websites, I finally picked three definitions which I thought best describes electrical and computer engineering. Here is what University of Toronto website page of engineering has to say. The electrical and computer engineering program prepares you for a wide range of engineering study and career options including business, biomedical, computer hardware, aerospace, computer software, nanoelectronic chips, photonics, nanoengineering, robotics, and solar energy harvesting and distribution. According to the Penn State University, the ECE definition is their program prepares them for students for a wide range of engineering study and career options, including electrical and electronic system design, microprocessor, automation, PLCs, instrumentation and control, computer programming, and electrical testing. According to Worcester Polytechnic Institute, the Electrical and Computer Engineering program at WPI offers engineering education on diverse subjects, including machine learning, cryptography and information security, signal processing, autonomous vehicles, smart health prosthetic control, analog and digital microelectronics, and wireless information networks. Interestingly, the definition and scope of ECE may change from school to school, as those are defined by the expertise possessed by faculty in the department within the school. For example, some departments are analog focused and some are digital focused. Some are focused upon biomedical applications, or some may be focused upon military application. It all depends upon the strength and diverse range of ECE sub-areas among the faculty. Let's break it down. These all are the specialization areas, and you can pick any one of them for the graduate program in some school. Starting off with the electrical engineering. What are the subfields? We'll start off with the digital systems. Digital systems are about how computer understands, perform operations, and stores data using a binary sequence of ones and zeros. Remember, we all understand that we live in a digital world, but it's really analog under the hood. Microelectronics. In microelectronics, you'll learn about the construction, functioning, properties, and applications of semiconductor devices such as LEDs, transistors, and integrated chips. In photonics, you will learn about science and technology of generating, controlling, and detecting photons, which are particles of light. In nanotechnology, which is a branch of technology that deals with the dimensions and tolerance of less than 100 nanometers, especially the manipulation of individual atoms, molecules, which make up a crystalline structure. A good example of nanotechnology are thin film transistors that are used in LCDs. Controls. Controls apply automatic control theory to design systems with desired behavior in control environments. In a communication system, which is a collection of individual communication network, transmission systems, relay stations, tributary stations, and data terminal equipment, you will learn about their capability of interconnection and interoperation to form an integrated whole. Signal processing. Signal means information and processing means operations. It means how information in the form of signal is operated or modified to get desired signal, and how system process these signals. Any information generated in this world is a signal. It could be an image, an analog voice signal, or digital signal of the processor. Energy conversion. It is the process of changing one form of energy into another, such as nuclear energy into heat or solar energy into electrical energy. In a power distribution area, you will learn about how electricity is being carried from the transmission system to individual consumers. You will also learn about the latest technologies and methodologies which imply microgrid system and integration of solar cells, wind turbines, biomass, and various other renewable forms of energy. In electromagnetic, you will learn about the electromagnetic fields which are caused by the electric charges at rest in motion. It is the study of nature and interaction of static and dynamic electric and magnetic fields. And finally, robotics. Many people don't even know that robotics actually is a sub-area of electrical engineering, in which you will learn about design, construction, operation, and use of robots, as well as computer systems for their control, sensory feedback, and information processing. Now let's look at the specialization areas that comes under computer engineering. Multimedia systems. It is a system capable of processing multimedia, data, and applications. It is characterized by the processing, storage, generation, manipulation, and rendition of multimedia information. Artificial intelligence, along with machine learning, is one of the hot topics in the current world. It is a branch of computer science that emphasizes the development of intelligence machines, thinking and working like humans. For example, speech recognition. Siri, how are you? Microprocessors, an integrated circuit that contains all the functions of a central processing unit of a computer. A very important topic under computer engineering. Memory systems, we all know about the importance of storage in the digital world. Network. In this subfield of computer engineering, you will learn about how a group of two or more computer systems are linked together. There are many types of computer networks, LAN, WAN, and here's your opportunity to learn about it. You might have heard of the blockchain technology and the cryptocurrencies. In order to understand how those blockchain strategies work, network is a very important area to understand. Integrated chips, circuits, they also come under both electrical and computer engineering. They're often called chips. They combine multiple discrete electronic devices onto a single substrate, which is usually a piece of silicon, utilizing the capabilities of semiconductor materials. Data analytics, again, one of the hot topics in today's world. It is the science of analyzing raw data in order to make conclusions about that information and basically making smart decisions. Hardware system, which basically refers to the physical parts or components of a computer. System hardware includes components such as the CPU, hard disk drive, graphic cards, sound cards, RAM, power supply unit, motherboard, etc. And programming is also one of the critical components of computer engineering. You will mainly learn about C++, Java, Python, and basically take this process of taking an algorithm and encoding it into a notation so that it can be executed by a computer. Let's talk about some of the impact by the electrical and or computer science engineers over a period of time. I have chosen 9 of these famous people who were electrical or computer engineers or electrical or computer or only computer science engineers. The first up is Nikola Tesla. Who doesn't know him? Born in Croatia, immigrated to the United States in 1884, Tesla was able to develop many important alternating current technology, challenging the growing consensus in favor of direct current, which Edison championed. Tesla sold many of his patents to George Westinghouse, facilitating the emergence of the AC power plants nationwide. If you are using electricity right now, you should thank Nikola Tesla. Thank you, sir. Second, Alexander Graham Bell moved to Boston in 1871 to begin work on an upgraded telegraph machine that would allow for sending and receiving multiple messages simultaneously. Bell's new ideas frustrated his investors but inspired his partner electrician Thomas Watson. Between 1874 and 1876, the two successfully developed the first voice transmitting device, which we know as a telephone. Eric Schmidt. He recently resigned as the executive chairman of the Alphabet, which is the Google parent company where he worked for 17 years. However, he's still working as a technical advisor. Eric co-founded Innovation Endeavors, which is a capital venture firm that has to date raised $676.5 million. Schmidt has a net worth of $14 billion, making him the 106th billionaire in the world. He's also the 22nd richest person in tech, according to Forbes. Edith Clark. I'm pretty sure not many of you know her, but she is an ideal candidate to idealize. As the first professional female electrical engineer, in 1922, Edith Clark made history during a time when women were still not considered for STEM roles. But Clark's impact in the field was important for transcontinental telecommunications. She patented a device that sent power through very long electrical transmission lines while she worked at GE, which we know as General Electric. Clark was also the first woman to earn an electrical engineering degree from MIT. Her most famous contribution was the Clark calculator in 1921, a graphical device that simplified the equations electrical engineers used to understand power lines. Jeff Bezos. According to Forbes, Jeff's fortune to be around $112 billion, making him the richest of the richest engineers. The founder and CEO of the largest e-commerce, electronic commerce platform, Amazon, has an electrical and computer science engineering degree. Jeff has soared to the top of Forbes billionaire ranks as Amazon stock rocketed over the last year or so. This rapid climb is partly due to Amazon's cloud computing unit, Amazon Web Services, also known as AWS. Bezos owns around 17% of Amazon.com and boasted in 2016 to shareholders that Amazon is the fastest company of all time to reach $100 billion in annual sales. Then comes Mark Zuckerberg. He has a net worth of $71 billion according to Forbes. This places him in the 4th place for the richest person in the world and 13th most powerful person on the planet. Mark's net worth has soared as Facebook's stock price has skyrocketed. He is another university dropout who has done very well indeed. Thank you. Mark left Howard University in 2000 at the age of 19 to launch the global giant that is Facebook. Salman Khan. Most students know him because he just makes things so much easier for students through sharing his resources and his experience and his understanding of diverse range of topics through his YouTube channel and his website known as the Khan Academy. We now have Satya Nadella, the CEO and Chief Executive Officer of the Microsoft. Nadella rose steadily through the ranks of Microsoft management. By 1999, he had been named Vice President of the Microsoft B Central Small Business Service, and 2 years later, he became Corporative Vice President of Microsoft Business Solutions. In 2007, he was elevated to Senior Vice President of Research and Development for the company's online services division, and he later served as President of Microsoft Server and Tools business, which annually generated some $19 billion in revenue. Nadella was also Executive Vice President in charge of the company's cloud computing platform, which provided the infrastructure for such Microsoft offerings as the online search engine Bing, the Xbox Live broadband gaming network, and the Office 365 subscription-based services. And last but not the least, Yoki Matsuoka. She is the Vice President of Technology and Analytics at Twitter and formerly the Vice President of Technology at Nest, where she was in charge of UX and the learning aspects of Nest Thermostat. Previously, she was an Associate Professor of Computer Science and Engineering at the University of Washington. Her research combined neuroscience and robotics to create more realistic prosthetics. All these people have great significance and tremendous amount of contribution towards electrical and computer engineering. Top prospects. Besides development, design, operations, and research, ECE engineers may be involved in manufacture installation and sale of the electrical and electronic equipment. They work on motor vehicles, power plants, computers, and electro-optical devices. They may deal with motors, lighting, lasers, radar, or medical equipment. Subspecialties range from tiny consumer electronic devices to the massive power generating equipment used by utility companies. According to National Society of Professional Engineers, 8 of the most in-demand engineering jobs for 2019 include number 1, data science and machine learning. Number 2, automation and robotics engineering. Number 3, software engineering. Number 4, petroleum engineering. Number 5, electrical engineering. And number 6, alternative energy engineering. Number 7, mining engineering. And number 8, project engineering. If you are in United States, some of the southern and northeastern states are the best places for an electrical and computer engineer to work. Interestingly, according to the US Bureau of Labor Statistics, the employment numbers for electrical engineers by state has not changed much since 2012, which actually is a good reflection of the stability of the ECE program in the nation that continues to form the core basis of engineering understanding. The employment rate is expected to go up as more and more manufacturing jobs will be created thanks to the growing economy. Career outlook, salaries. Electrical engineering and computer engineering are some of the fastest growing career fields in the United States, and they pay well. Starting salaries are typically near $60,000 for entry-level engineering jobs. For bachelor's degree graduates with a master's or PhD degree, you could even make $80,000 or $100,000 a year at your first full-time job. This was according to the press release from Iowa State University. This data right here covers 2 different salary categories. One is the starting median salary, the median of what people were earning after they graduated with their degree, and you see the electrical and computer engineering. Electrical engineering is number 3 on the list and computer engineering is number 2nd on the list. Second salary category is mid-career percentile salary data from 10 years after graduation, sorted by percentile. In other words, the starting median salary represents what people started making after they graduated, and the rest of the chart depicts the range that people were making 10 years after they got their degree. Lower earners are lower bound and higher earners are the upper bound, which is the 10th and the 90th percentile. ECE starting median salary was $61,000 and median mid-career salary was $105,000. So that's pretty good money. There has been many significant development and advancement in ECE, electrical and computer engineering. Most recently, the researchers at Oregon National Laboratory have created a new modeling tool that allows for a better understanding of a powerful engine that could propel the next generation of aircraft. There has been recently a lot of focus on artificial intelligence, and machine learning has taken up a spike. Researchers are now using genetic algorithms to develop better superconductors, which can make faster computers. According to researchers at University of California, San Diego, engineers have developed a high-throughput computational method to design new materials for next-generation solar cells and LEDs with higher efficiencies. These are the few among many development and advancement that have taken place recently in the field of electrical and computer engineering. With this, I'm going to finish this presentation and hope that you all will make the right choices in your lives. But before you go, I want to give all of you one sincere advice. Whatever you choose to do in your lives, say you want to be a plumber or carpenter or any kind of engineer or doctor, be the best in what you do. And success is all yours. No one can stop you. Enjoy your rest of the day.